Lesson 5-2, Two-Step Equations. 3x minus 5 equal 20 is an example of a two-step equation. This is called a two-step equation because it takes 2 steps to solve. We have a few things we want to label in this equation, the different parts of it. 3 is called a coefficient because it is a number that is multiplied by a variable. X is a variable. It is a letter that is representing a number that varies. -5 and 20 are both called constants because they are numbers that don't change. They remain constant. Example 1, we're going to solve and check your answer. So let's box in the term that includes the variable c. Our goal is to get c by itself, but we're going to start by boxing in the term that includes c, and we see that there's a +3 on the left side of the equal sign with it. So we're going to get rid of that +3 by subtracting 3. When we have +3 minus 3, they cancel out. So we get 9c equal 36. Now we have 9 times c. We want to undo multiplying 9 by dividing both sides by 9. 9c divided by 9 is 1c, or just c. 36 divided by 9 is 4. So we've solved this. Notice that it had 2 steps. Our first step was subtracting 3 from both sides. And then the second step was dividing 9 from both sides. We can check the answer by just plugging in what we got. 9 times c plus 3, we want to see if it equals 39. So we're going to plug in what we got for an answer. 4. 9 times 4 is 36, plus 3 is 39. So since these were equal, then that is true. The answer was correct. B part, 9 equal x over 7 minus 11. So I'm going to box in this term that includes x. You might think a term can't have division in it, but really this is like 1/7 times x is another way of looking at it. So that could be rewritten as a number times x. So it is still a term. And so we want to get rid of this minus 11 by doing its opposite, which is add 11 to both sides. When we're getting rid of a term, it's always being added or subtracted. So 9 plus 11 is 20, equal x over 7. And so to undo dividing 7, we're going to multiply both sides by 7. On the right side, when we divided 7 and multiplied 7, they canceled out and we just have x. On the left side, 7 times 120 is 140. So we get x is 140. Notice in pink that we added 11 to both sides. That was the first step. And notice in orange, we multiplied both sides by 7. That was the second step. So we solved this in 2 steps. To check our answer, we have 9 equal x divided by 7 minus 11, where x was 140. And we want to see if this is correct. So on the left side, we have 9. And then 140 divided by 7 is 20. 20 minus 11 is 9, so yes, this was correct. Example 2, we are solving equations only. We're not showing our work for checking them, but you can go through and check your answer in the same way. So in this equation, we're going to box in the term that includes m because that's the goal, to get m by itself. So first we'll get the term by itself. We'll get rid of this +6 that's on the same side of the equal sign. A +6 minus 6 is 0. They canceled. -34 minus 6 is -40. So we've got negative 40 equal negative 4m after the first step. Now we want to get rid of this negative 4 times m by dividing both sides by negative 4. Negative 4m divided by negative 4 is just m on the right side. And negative 40 divided by a negative 4 is a positive 10. So 10 is m. B part, 6 plus y over 5 equal 21. So I'm going to start by boxing in my y term, including the sign to the left. I'm going to get rid of this positive 6 by subtracting 6 from both sides of the equal sign. And what will happen is we have y over 5 remaining on the left side equal 15 on the right side of the equal sign. Now we have a little one-step equation. We're going to undo dividing 5 by multiplying both sides by 5. So they cancel on the left side and we just get y. On the right side, 15 times 5 is 75. C part, we have w minus 2, which is a group, divided by 5 equal negative 1. It's a group because it's separated by a fraction line. I could approach this a couple different ways, but one of the simplest ways is just to make it a non-fraction problem. So to do that, I'm going to cancel my denominator. This is a special case involving fractions, and I'm just going to cancel my denominator. It was dividing 5, so now I'm going to multiply by 5. What we do to one side, we have to do to the other. So when I divide 5 and then I multiply 5, they cancel out, and what remains on the left side is w minus 2. On the right side, negative 1 times positive 5 is negative 5. And now, I just want to get w by itself, so I'm going to add 2 to both sides. And I get w equal negative 3.